The purpose of this lesson is to show how you can use Inventor to choose the material with the least environmental impact for your product. In this case, we'll be looking at the handlebars of your bike. Different materials have different properties. Think of plastics and steel. Steel is harder, stronger, and fails in a different manner than plastics. Steel fails all at once, while plastics fail slowly. What's more, plastics are less expensive and less dense than steel. That is, plastics take up more volume for an equal mass. With all these different properties, we need to find a way to compare these materials fairly. We do this with a functional unit. A functional unit is all the parameters that are necessary to fulfill the use scenario of that product. For example, if we were designing a shopping bag, we would want to find the average weight of groceries. Let us say it's 50 pounds. Now, whatever material you use, paper, plastic, cotton, it has to hold 50 pounds. That is your functional unit. You will need more paper than plastic to hold this 50 pounds. Think of how thick the plastic bags are compared with paper. It turns out you need 10 times more paper as you need plastic to make a functional grocery bag. So for the two materials to have the same environmental impact, the paper bag would have to be 10 times less impactful. Now let's apply this concept to the bike handlebars. What properties do our handlebars need? Here are a few we might want to use. They need to be strong enough not to break under your weight when you lean on them. They need to be stiff enough that they don't bend when you turn the bike. They need to be big enough around that you can grip them, and not so big that you can't get your hands around them. This means our functional unit is handlebars that can turn the bike without breaking. The aluminum handlebars for a standard road bike, like the one used in our bike, meet all of these criteria. So, if we want to use a stronger material, we won't have to use as much material as the aluminum bars. Since the outer diameter of 25.8 millimeters will work for an adult human grip, we can make the handlebars thinner by increasing the inner diameter. The math of determining how much thinner is not covered in this presentation, but if you're interested in material strength, you should research tensile strength. The inner diameters we'll use for the aluminum bar is 17.8 millimeters, for the titanium is 22.5, and for stainless steel is 15.6. Now that we have the functional unit, we can use this to evaluate the relative environmental impacts of different materials. To do this analysis, we will use Inventor's Eco-Material Advisor. First, we have to open up the handlebars for LCA IPT. Then, we run an environmental impact analysis by clicking on the Environments tab on the ribbon and select Eco-Material Advisor. At the opening of the Eco-Material Advisor screen, select the Browse option. We expand the Typical Materials drop-down by clicking on the plus symbol to the left of it or on the name itself, and expanding non-ferrous metals. Non-ferrous means not containing iron. Click on Aluminum Alloys, Wrought, and then select Assign to Selected Part. When prompted, click Assign Materials from the dialog box. Select View and Edit Assignments button, the one that looks like two arrows at the top of the panel. This will bring you the Material Assignment panel. For assembly files, you can assign different materials and different processes to different parts. But for our part, we'll click Aluminum under the Material heading and select Show Processes. Click on Forging and Rolling and select Assign to Selected Part. When prompted, select Assign Process in the dialog box. Return to the View and Edit Assignments view to ensure you have accurately defined the material and processes for the handlebars. It is likely that the tube for the handlebars were extruded, bulk metal pressed through a donut-shaped hole like spaghetti or Play-Doh. To get unique information on other processes, you need to upgrade to the full version of EcoAdvisor. But for now, we can stick with the forged or rolled. After ensuring that you have correctly assigned the parameters, select the View Dashboards option from the top of the panel, the one that looks like a line graph. At the bottom of the panel, you should see the Eco Impact Board. So what is the meaning of these numbers? To make any material, it takes energy. In the case of most metals, you have to dig them out of the ground, heat them up, cool them down, then clean them, and finally form them into the stock material type you desire, using manufacturing processes such as rolling, extruding, or casting. Each of these steps takes electricity, fuel, or water. The Ecomaterial Advisor has a database with the amount of energy, water, and CO2 released per unit mass for each of these materials. It also has data on the resources used in different manufacturing methods. The number we see here are the values applied to your unique model. Record these numbers on your worksheet as you will need them later. Now, let's look at how this compares to other materials. Start by clicking on the Set Baseline button in the Ecomaterial dashboard. This is on the lower right-hand corner of your screen. This will allow us to quickly see how one material compares to another. Return to the Browse for Material panel by clicking on the icon that looks like a mouse cursor. Set the material to titanium. This will also be under the non-ferrous metal group. Notice how the dashboard shows green and red bars to indicate where the new material performs better and where it performs worse. You may be scratching your head. It seems like if we were to use titanium, we would need a lot less of it, and so the impact would be less. And you'd be right. We need the functional equivalent of the aluminum handlebars, but that means we need to change the model. To alter the model, exit the Ecomaterial Advisor by clicking on the Finish Ecomaterial Advisor button in the Environments tab on the ribbon. After exiting the Ecomaterial Advisor, change the view to show the hollow end of the handlebars. You can do this quickly by clicking on the corner of the view cube in the top right of the main window. To match our functional unit for our handlebars, we need to keep the outer diameter the same while changing the inner diameter of the handlebars. To alter the inner diameter, select the Parameters option under the Manage tab on the ribbon. When you have opened the Parameters window, scroll to the bottom and edit the parameters named Handlebar ID. Change the parameter to the value we calculated for titanium and click Done. You should see a change in the geometry of the model. For example, here's the same part with a larger inner diameter of the tube, i.e. thinner walls. You can now return to the Ecomaterial Advisor, edit the material or the manufacturing process and see the results, which now include the updated geometry. You should repeat this process for the stainless steel as well. Using this tool, you can find the material that meets all of your needs while having the least environmental impact.